Imagine if we could run a petabyte scale data analysis at less than half the cost of traditional on-premise solutions. Hi, this is Al, a product manager with the Amazon EMR team, and let's talk about what's new with Amazon EMR that can help you save cost and run 1.7x faster than Apache Spark 3.0 without the runtime. Amazon EMR is the industry-leading cloud big data platform for processing vast amounts of data using open source tools such as Apache Spark, Apache Hive, Presto, Apache Hudi, and many more. In today's session, we will discuss some of the common architectural patterns on EMR and then dive into new enhancements into the service. Data engineering platforms are evolving, and there's a common pattern across multiple data engineering platforms. You have clients like notebooks or edge servers that are on one side, which are used by data scientists and data engineers. The most common orchestration systems that we see are Apache Airflow and AWS Step Functions. In an on-prem world, a Hadoop cluster is a shared multi-tenanted environment, or a Spark cluster is a shared multi-tenanted environment. When customers move to the cloud, they're able to decouple storage and compute. And when they decouple storage and compute, a new architectural pattern comes from the picture. Because what you can do is you can run all of your data in S3 data lake, and you can either run a transient cluster like a pipeline, or you can run a persistent autoscaling cluster continuously. When customers move to EMR from running on-prem, they can choose either running a long-running cluster or a transient cluster, or they can choose to run a combination of these two types. But the thing that's really common is that both of these clusters are processing data from the same Amazon S3 data lake on the cloud. In this pattern, the data always resides in S3 data lake instead of HDFS. When customers ask us which pattern they should run, we tell them it's a choice. Long-running clusters, which are always running, are good for lines of businesses. Each line of business is given one persistent long-running autoscaling cluster where multiple teams can run jobs on the same cluster. If you have a large number of short-running jobs that you want to run at regular frequency by leveraging long-running clusters and use autoscaling for those clusters, then you can save costs for multi-tenanted data science and data engineering jobs. When you're trying to save costs under multi-tenanted environments, transient and job scope clusters are really good. Jobs that run for more than 30 minutes feel like a long-running job. This allows you to separate long-running jobs into individually run job scope clusters. And the biggest benefit is that you can separate production pipelines from each other and from non-production pipelines. If one pipeline fails, then the other pipelines don't have to suffer. As a common architectural pattern for data platforms have evolved across clients, across orchestration services, and across managed clusters, we'll talk about the improvements we have made across the board. Let us talk about these improvements by focusing on 5 themes for this discussion. We'll pick themes because we'll continue to focus on these themes and our features are related to these themes. The first theme is on Amazon's open source currency and deployment models. EMR keeps to a 4 to 6 week cadence on releases. We fast follow open source libraries by 60 to 90 days. With EMR, you get a variety of different deployment models. Next up, we'll talk about differentiated performance and lower costs with EMR Runtime for Apache Spark, Hive performance improvements, hardware performance improvements, and improvements on Spot and Managed Scaling. EMR has a new simplified user experience with EMR Studio in preview. EMR Studio is an integrated development environment, or an IDE, that makes it easy for data scientists and data engineers to develop, visualize, and debug data engineering and data science applications. We'll talk about building better data lakes with Apache Hudi, and we'll conclude with an update on security and fine-grained access control with AWS Lake Formation and URM. Let us talk about some of the performance improvements available out of the box on EMR for Spark, PrestoDB, and Hive. Amazon EMR Runtime for Apache Spark is a performance-optimized runtime environment for Spark that is active by default on Amazon EMR clusters starting EMR 5.28 and later. Amazon EMR Release 6.1 contains Spark 3.0 with the EMR runtime. To evaluate the performance improvements on EMR, we used a TP-CDS benchmark queries with 3 TB scale and ran them on 6-node C4 8XL clusters with data sitting in Amazon S3 and compared the performance of EMR version 6.1 with and without the runtime. Benchmarking results show that EMR runtime provides query performance of up to 1.7x faster when compared to running without the EMR runtime based on geometric mean. All queries improved. EMR 6.1 is 100% API compliant with open source Apache Spark API. We discussed Spark 3.x, now let's focus on Spark 2.4. We are making continuous improvements across the board with EMR runtime for Spark. To evaluate the performance improvements with EMR runtime with each version, we compared performance of EMR versions 5.30 and 5.28, both with the runtime. We used a similar TP-CDS benchmark and we found that EMR 5.30 is up to 17% faster by geomean compared to EMR 5.28. EMR 5.30 with runtime is up to 3x faster by geomean when compared to EMR 5.16, an earlier version without the runtime. As you can see, EMR runtime is continuously improving under the hood. You can run your workloads faster and cheaper without making any changes to your applications by just upgrading to the latest version of EMR. EMR runtime for Apache Spark achieves this performance improvement with several optimizations under the hood, including adaptive query execution, also known as AQE. AQE is a new framework in Apache Spark 3 that re-optimizes query plans based on runtime statistics. This framework is available today on EMR runtime for Spark. With EMR runtime for Spark, it'll allow you to benefit from AQE on Spark 2.4 on EMR release version 5.30 without migrating to Spark 3 on EMR 6.1. The AQE optimizations speed up TP-CDS queries by up to 8.2% by geomean. We are introducing Amazon EMR runtime for PrestoDB, a performance-optimized runtime environment for PrestoDB that is available and turned on by default on Amazon EMR releases 5.30 and later. To measure these improvements, we compared EMR 5.31, which includes EMR runtime for PrestoDB, and compared it with EMR 5.29, which does not have the runtime. We used TP-CDS benchmark queries with 1 TB scale and ran them on a 6-node R4 8XL EMR cluster with data in S3. Results show that EMR runtime for PrestoDB, your queries run up to 2.6x faster by geomean. EMR runtime for PrestoDB is 100% API compliant with open source PrestoDB, so you can continue writing applications using open source APIs. Your workloads run faster without changing your applications. Let us discuss performance improvements for Apache Hive. To evaluate the performance benefits of running Hive with EMR 6.0, we compared it with EMR 5.29. We benchmarked this comparison using 70 TP-CDS queries on a 3 TB Apache Parquet dataset on a 6-node C4 8XL EMR cluster. The results show that these TP-CDS queries ran twice as fast on EMR 6.0 with the default Amazon EMR Hive configuration. Hive LLAP or Hive Long Live and Process is optional on EMR 6.0 and all Hive queries executed using dynamically allocated containers when Hive LLAP is disabled. To illustrate the differences of running Hive queries with persistent Hive LLAP daemons versus dynamically allocated containers, we use a subset of the TP-CDS benchmark, and the results show an overall performance improvement of up to 27% with LLAP compared to running on containers. Drop Technologies provide a personalized commerce platform and our Amazon EMR customers. Drop data lake infrastructure plays a foundational role in enabling better data-informed product and business decisions. Drop saw an immediate performance gain by upgrading from Amazon EMR 5.27 to 5.29 version without having to make any additional changes to their existing pipeline. They improved their pipeline from using the Amazon EMR Runtime for Spark feature introduced in Amazon EMR version 5.28. When they benchmarked these improvements against 2 of their datasets and averaged it against 3 production runs, they found that their EMR costs were reduced by 50% using identical resource configurations, and they got results 5x faster. Amazon EMR now supports Amazon EC2 M6G, C6G, and R6G instances to deliver the best price performance for big data workloads. These instances are powered by AWS Graviton 2 processors that are custom designed by AWS using 64-bit ARM Neoverse cores. The combination of EMR Runtime for Spark and Graviton 2 instances offers up to 15% improved performance and 30% lower costs compared to running previous generation instances with the runtime. The combined benefit of EMR Runtime for Spark and Graviton 2 processors offers up to 76% lower cost and 3.6 times improved performance compared to running on equivalent previous generation instances without the runtime. EMR has been working to reduce spot interruptions for customer workloads. This graph shows a percentage of spot clusters terminated globally due to spot reclamations each month. You can see that spot interruption was already low at about 0.03% in November 2018, but we refactored our algorithms to take into account of not only where the capacity was, but also how fast the capacity was getting consumed. Interruption rates since last year have been consistently low, and we're approximately 3x lower at about 0.0009% in May 2020. Amazon EMR now offers a capacity-optimized allocation strategy for provisioning spot instances in an Amazon EMR cluster. Capacity-optimized allocation strategy uses real-time capacity data to allocate instances from spot instance pools with optimal capacity for the number of instances that you're launching. Allocation strategy option allows you to up to 15 EC2 instance types per task instance fleet when creating your cluster with instance fleet configuration. This is up from 5 instance types per task fleet previously. By diversifying your spot requests across these 15 different pools within each availability zone, you can reduce the impact of spot interruptions on your workload if EC2 reclaims a spot instance. This allocation strategy is appropriate for workloads which have a higher cost of interruption. Examples include long-running jobs and multi-tenanted persistent clusters running Spark, Hive, and Presto. By offering the possibility of fewer interruptions, the capacity-optimized allocation strategy can lower the overall cost of your workload. EMR Managed Scaling is a new feature that automatically resizes your EMR clusters based on best resource utilization without the need for you to author or configure complicated scaling policies. With Managed Scaling, you just specify the min and the max compute limits for your clusters, and EMR automatically resizes your clusters based on continuous sampling of key metrics associated with the workloads running on your clusters. Managed Scaling is useful in scenarios where the load on your cluster is unpredictable or the amount of data processed by the cluster can change over time. With EMR Managed Scaling, you can save 20 to 60% of your costs depending on your workload pattern. Let's take a closer look. Before EMR Managed Scaling, you had to predict workload patterns in advance or write custom auto-scaling rules that depended on in-depth understanding of the application framework, for example, Spark or Hive. Predicting your workload or writing custom rules can be very difficult and error-prone. Incorrect sizing of cluster resources can often lead to either a missed SLA or unpredictable performance or underutilization of resources and cost overruns. Customers told us that do-it-yourself auto-scaling has a few limitations. DIY autoscaling depends on CloudWatch metrics, which leads to 5-minute lead time, and the scaling is stepped and gradual. It also does not work with instance fleets, which limits you from using spot instances. Managed scaling addresses these limitations by working with instance groups and collects metrics every 5 seconds and evaluates every 10 seconds. This allows managed scaling to get continuous evaluation and dynamic scaling capability. To illustrate by example, we configured a EMR cluster with EMR Managed Scaling to scale between 1 and 20 nodes with a 16 vCPU per node. We submitted multiple Spark jobs from the TPCDS benchmark to the cluster at 30-minute intervals. We set the cluster settings to default and turned on managed scaling. Enabling managed scaling in this use case lowered cost by 60% compared to cost of running a fixed cluster. EMR managed scaling can be used for both persistent and long-running clusters, but also transient EMR clusters that shut down after the workload finishes. Nielsen Holdings is a global measurement and data analytics company. Nielsen Marketing Cloud built a multi-petabyte data platform using Amazon EMR. They build marketing segments and device graph data, which are used for targeting campaigns and making business decisions. Nielsen Marketing Cloud told us that managed scaling has allowed them to significantly improve their developer experience. With managed scaling, they were able to improve their developer experience because they are flexible to keep running their long-running clusters for longer without dramatically increasing their costs. ZS Associates is a global professional services firm that helps companies develop and deliver products for their customers. ZS Associates leverage EMR with Apache Spark heavily for data analytics strategy. Previously, tuning the DIY scaling policies with appropriate parameters was a challenge for the data engineering team, and they had to closely monitor the workload changes and update the parameters. They told us that managed scaling has made it really easy for them. The simplicity of the feature, coupled with their central governance, will allow them to adopt managed scaling and numerous EMR Spark workloads quickly. They're seeing a 30% cost reduction and plan to enable managed scaling for all of their future workloads. Let us summarize this theme. With a combination of faster runtime with 100% compatibility with open source APIs, differentiated hardware for lower cost, better reliability from Spot, and managed scaling, EMR provides lower cost and higher performance with every release out of the box. With that, let's switch gears to talk about a new simple user experience on EMR. EMR Studio in preview is an integrated development environment or IDE that makes it easy for data scientists and data engineers to develop, visualize, and debug data engineering and data science applications written in R, Python, Scala, and PySpark. EMR Studio provides a fully managed Jupyter Notebooks experience and tools like Spark UI, Yarn Timeline Service, and Thais to simplify debugging. EMR Studio is currently in preview. Let us look at the new simplified EMR Studio experience.
EMR Studio is a completely new notebook-first integrated development environment or IDE experience with Amazon EMR. Let us log in to EMR Studio. You can see here that we were able to log in with my corporate identity. EMR Studio provides workspaces which organize your team's fully managed notebooks. Let me open up my workspace. Data scientists and data engineers can single sign on using their corporate identities and don't need to go through the AWS console to access their notebooks. Once logged in, you can work on fully managed notebooks based on the familiar Jupyter Lab interface. Studio gives you the flexibility to create notebooks independent of clusters. You can parameterize your notebooks and you can also execute your notebooks programmatically using Airflow or AWS step functions. You can chain and parameterize your notebooks, and this gives you the option to test and deploy your workloads quickly using Spark. You can add custom kernels and Python libraries conveniently from your notebooks, and you will not require to do a multi-step installation process on the underlying clusters. Now let's run this notebook and take note of the cluster name to which this notebook is attached to. As you can see here, the cluster is attached to this notebook, and you can detach the notebook from the cluster at any time. This gives you the ability to detach your cluster from a development environment to move to a testing environment, for example. If you do not have a cluster available for your notebook, you have the ability to create a cluster for your workspace, either from scratch or from templates that are pre-configured by your administrator. With Studio, you can easily collaborate with your peers by connecting to AWS Code Commit, GitHub, or Bitbucket. You can also create Git repos at any time. You can see here that our Spark job is run. And if you want to debug this, EMR Studio gives you a very simplified debugging experience. Let's go back to Studio and look at clusters. You can browse all the clusters in one place for this workspace and narrow down to a cluster or a job that you want to investigate using filters. Let us filter to the cluster that we ran our notebook on, which ends in UKRX. You can overlay execution context on jobs, even for terminated clusters and jobs. And you can diagnose your job both on active and terminated clusters using Spark UI, Taze UI, and Yarn Timeline service. Here, we're looking at the application that we just ran, and you can easily look at the event timeline. You can go into the job that you just ran, look at the DAG visualization, look at the completion stages, and dive a little bit deeper. Now let's switch back to our presentation, and let's talk about how EMR Studio can benefit you in detail.
EMR enables you to get single pane of glass for data science. Users can log in directly to their notebooks with their corporate identities. It's a single toolset for building and deploying applications. You can share notebooks via GitHub and other repositories, can run pipelines with notebooks using Apache Airflow or AWS step functions, and you can simplify debugging with Spark UI and Yarn Timeline service. Let's look at each of these closely. EMR Studio provides a multi-tenanted experience where multiple users and groups can log in to the same studio. You can single sign on with your corporate identity using AWS SSO, and you don't need to log in through the AWS Management Console. Administrators can easily connect external identity providers to AWS SSO, create and configure studios, assign users and group to studios, and restrict user or group permissions. Data scientists, data engineers, and analysts can log into multiple notebooks using corporate identities. For example, it may be a different project that you may be working on. Multiple users can log into the same studio. For example, if you're part of the same team. Once logged in, you can work on fully managed notebooks based on JupyterLab. Studio gives you the flexibility to create notebooks independent of clusters. You can attach or detach notebooks in Studio to EMR clusters using a single click at any time. For example, you could develop and test your notebook on a development cluster and then switch to a production cluster when your code is ready. If your workspace does not have a cluster, you can provision EMR clusters using cluster templates that are pre-configured by your administrator or create a new cluster from scratch. With Studio, you can connect to AWS Code Commit, GitHub, and Bitbucket to collaborate with your team. You can add custom kernels and Python libraries from notebooks, and it does not require a multi-step installation process on the underlying clusters. You can build pipelines with your notebooks by chaining and parameterizing them, and orchestrate with Apache Airflow or AWS step functions. Studio gives you a simplified debugging experience. You can browse all of your clusters in one place. You can narrow down to a cluster or a job for investigation using filters. You can overlay execution context on jobs, even for terminated clusters and jobs. And you can diagnose jobs on both active and terminated clusters using Spark UI, Taze UI, and Yarn Timeline Service. Studio is currently available on preview. Let us transition to talk about building transactional data lakes. To enable customers to perform record-level inserts, updates, and deletes for privacy regulations, change data capture or CDC, and simplified data pipeline development, we started supporting Apache Hudi on EMR. Storing your data using Hudi open formats allows you to build your CDC pipelines efficiently using open source tools like Spark, Hive, and Presto. In June 2020, Apache Hudi graduated from incubating into a top-level project. We congratulate the entire Apache Hudi community on achieving this major milestone. Now, you can query the latest snapshot of Apache Hudi copy on write datasets from both Amazon Athena and Amazon Redshift Spectrum using snapshot isolation. There's no need for you to create any manifest file or additional tables with this new feature. Apache Hudi recently integrated with AWS Database Migration Service or DMS, which allows you to ingest data from an upstream relational database to your Amazon S3 data lake in a seamless, efficient, and continuous manner. With the latest Hudi release version 0.6.0, EMR team has collaborated with the community to add an experimental bootstrap operation which performs up to 5 times faster on regular bulk insert operations. With this operation, you can use Apache Hudi with your existing data without needing to rewrite the dataset. Finally, let's talk about fine-grained access control on EMR. By default, all EMR application processes assume EC2 instance profile and an EMR service IAM role. Everyone accessing an EMR cluster shares the same IAM permissions. This makes column-level access control hard or challenging for multi-tenanted clusters. EMR now integrates with AWS Lake Formation to simplify fine-grained access control policies for Spark applications submitted using Apache Zeppelin or EMR notebooks. Lake Formation is a centralized repository where you can define access policies for AWS analytics services, including Amazon EMR, Redshift Spectrum, Glue, and Athena. With Lake Formation, you can enforce database, table, and column-level policies for data stored on your S3 data lake. With EMR and Lake Formation integration, you can enable metadata protection with Spark applications by Amazon EMR Record Server, enforce Lake Formation permissions cross-account. You can audit your access with AWS CloudTrail, and Lake Formation allows users to sign in via Security Assertion Markup Language or SAML 2.0, which is an open industry standard supported by most of the identity providers. This simplifies authentication for organizations using Active Directory Federation Services or ADFS like Okta or Auth0. Data scientists, analysts, and engineers don't need to log in via AWS Console or SSH into the EMR cluster. With a combination of SAML-based SSO and AWS Lake Formation policies, customers can securely run Spark applications on shared multi-tenanted environment with column-level access to data stored in Amazon S3. URM or user role mapping is a mechanism which allows you to map an IAM role to a user or a group from an identity store like Active Directory. When an application makes requests to obtain AWS credentials from the IMDS or Instance Metadata Service, URM intercepts these requests and instead returns AWS credentials for the IAM role that are mapped to the user or the group that's making the request. You can leverage IAM roles to segregate data access for multi-tenanted, Kerberized EMR clusters. URM supports union of permissions by mapping groups or users to IAM policies. URM is available as open source software from AWS Labs, and you're required to manage this package. And that brings us to the end of our presentation. Today, we discussed what's new with EMR and touched upon how you can take advantage of Amazon EMR today to stay current with open source currency and deployment models, lower your costs and get higher performance, simplify your user experience, build transactional data lakes, and set up fine-grained access control for your clusters. Thanks for being with us today. Please complete our session survey and have a good rest of your day.